Hello Year 8, welcome to Lesson 3 of Tectonics. For this lesson you will need a pen, paper, pencil and fact book. And this lesson is all about volcanoes. Your first activity is the quickfire round. So pause your video here, have a look at the 5 questions which are based on Lesson 1 and Lesson 2 and see if you can answer them all. From both our first and second lesson, we should be feeling fairly comfortable with the idea of tectonic plates, the oceanic crust, the continental crust, and this idea of boundaries. So as with earthquakes, volcanoes can be found in long belts following the plate boundaries. The biggest belt can be found around the Pacific Ocean and it's called the Ring of Fire. There is another one running down the middle of the Atlantic Ocean as well. Have a look at both of the maps and see if you can notice any patterns or similarities. So composite volcanoes is that typical volcanic shape. If we're asked to draw a volcano, this is the type of volcano that we tend to use. So composite volcanoes are found at destructive plate margins, when the oceanic plate sinks into the mantle and melts. It forms magma. Magma mixed with seawater then rises up through the cracks in the Earth's crust and erupts at the surface, forming volcanoes. Composite volcanoes have steep sides and are made up of alternative layers of ash and lava. The lava that comes out of this volcano is sticky, so it doesn't flow very far, and it's also very acidic. Eruptions from a composite volcano can be very violent, expelling steam, ash, lava and rock, but thankfully they don't happen very often. Pause the video here and use your paper and pencil to draw an annotated diagram of this composite volcano. You can see the diagram here has lots of different layers, it has lots of different labels, but use the information you've just been given to add extra detail. So shield volcanoes. These are found at constructive plate margins. As the two plates move apart, magma rises up from the mantle. Some magma is forced to the surface through a vent, which then forms the volcano. Shield volcanoes have a wide base and gently sloping sides. The lava for these volcanoes is really runny and flows a very long way. It's also basic. That's the opposite of acidic. They can be frequent in terms of eruptions, but they're not very violent. And did you know that Mauna Loa in Hawaii was formed in this way? Pause the video here and draw an annotated diagram of this shield volcano. One way of measuring eruptions is to use the Volcanic Explosivity Index. This measures the volume of material that has erupted. It's used for comparison to measure recent and past eruptions as well. Like the Richter scale for earthquakes, this Volcanic Explosivity Index is logarithmic. That means that each point on the scale represents an eruption 10 times bigger than the one below. So, a VEI 5 is 10 times bigger than a VEI 4 and 100 times bigger than a VEI 3. Volcanic eruptions can have a devastating effect on people and the environment. But unlike earthquakes, volcanoes can also have a positive impact on the area. We will look at these positive impacts in more detail in another lesson, but briefly, dramatic scenery created by volcanic eruptions attracts many tourists, and that can bring income into the area. Lava and ash deposited during an eruption breaks down to provide valuable nutrients for soil. And this creates really fertile soil, which is great for farming. High levels of heat and activity inside of the earth, close to a volcano, can provide opportunities for generating geothermal energy. And as you would expect, there are also many negative effects as well. Many lives can be lost as a result of a volcanic eruption. If the ash and mud from a volcanic eruption mix with rainwater or melting snow, fast-moving mud flows can be created. And these flows are called lahars. Lava flows and lahars can destroy settlements and clear areas of woodland or agriculture. It can have a big effect on habitats and wildlife. Human and natural landscapes can be destroyed and changed forever. Pause the video here. Study both the positive and negative impacts. And like we did with the earthquakes, see if you can break them down into the social, economic and environmental categories. Perhaps make a list or draw yourself a table. Volcanic eruptions aren't usually too much of a problem if you live in a country a long way away from a plate boundary, but beware the supervolcano. It's one of nature's greatest killers and capable of setting off a super eruption. A super eruption is the world's biggest bang. It's a volcanic explosion big enough to dwarf anything else and affect everyone on the planet. Put simply, they are volcanoes capable of erupting on a much bigger scale than a normal volcano. A supervolcano also looks different to a normal volcano because it often doesn't have a peak or a cone. In a normal volcano, magma flows up from deep inside the earth and pulls out of the cone, but in a supervolcano, the magma is blocked from reaching the earth's surface. So the pressure begins to build up, more rock melts and more magma is formed, creating an enormous magma chamber. When the pressure becomes too much, the entire surface above the magma chamber is blown away by a huge explosion, forming a caldera. Scientists think that there are about 6 or 7 of these supervolcanoes. At Yellowstone National Park in America, the caldera is so big that scientists had to use photos from space to check that it was a caldera. About 6.5 kilometres below the Yellowstone National Park is a 64-kilometre wide magma chamber. We have had supervolcanic eruptions in the past. In 1980, Mount St. Helens, also in America, erupted. The blast was so powerful that it blew 400 metres off the top of the volcano. It created a crater 3 kilometres long and 500 metres deep. Destroyed and flattened every single tree in a blast zone 25 kilometres north of the volcano. Impressive? But Mount St. Helens is just an ordinary volcano. A supervolcano could emit over 11,000 times more material than Mount St. Helens and create a global catastrophe. For instance, the Toba supervolcano emitted about 2,800 cubic kilometres of material when it erupted 74,000 years ago. So the impacts of a supervolcano is utter devastation. Magma would be flung 50 kilometres into the atmosphere. Virtually all life up to 1,000 kilometres away would be destroyed. 1,000 cubic metres of lava would pour out of the volcano, enough to cover the whole of the USA, 12.5 centimetre thick layer of lava over the entire country. The amount of ash and gas thrown up into the atmosphere by the explosion would dramatically reduce the levels of radiation from the sun reaching the Earth's surface. So this would trigger a freezing cold volcanic winter. But although a super eruption is possible and we can't stop it, Yellowstone supervolcano is constantly monitored to check for signs of activity. So it's likely that any threat of a catastrophic eruption would be picked up straight away. And thankfully, supervolcanic eruptions don't happen very often. The last one was at Toba, and that was 74,000 years ago. Pause the video here. Imagine that Yellowstone supervolcano has erupted. Write a news bulletin to say what has happened. Impacts in America and around the world. Have fun with it. Well done, Year 8. You've now reached the end of Lesson 3, all about volcanoes. If you need to, go back over this video and pause it as many times as you need, or even Lesson 2 and Lesson 1. What we would like you to do now is learn these 4 facts ready for your quiz in the next lesson.